So now we're going to get into a discussion of how we go about naming compounds that contain a special type of ion known as polyatomic ions. All right? So when we're talking about polyatomic ions, we're talking about basically an ion which is made up of two or more elements. All right? So here's an example. This is called the nitrate ion. And the nitrate ion consists of, as you can see here, one nitrogen atom and three oxygen atoms. And as a unit, it carries overall a negative charge, right? So this is a typical polyatomic ion, all right? Now, as a result of that, compounds containing polyatomic ions will be made up of three or more elements. And they usually consist of one or more cations combined with a negatively charged polyatomic ion. So here's an example of that. This is called sodium carbonate, and this is made up of two sodium ions and one polyatomic ion, which is known as the carbonate ion, which is CO3. All right. In fact, let me see if I have the breakdown here. Okay. So basically, let me see if I can find the pen function here. So basically, in this case here, we have two sodium ions, each of them carrying a plus charge, and the carbonate ion, which has this formula, and you'll notice that it has a -2 charge, right? And basically, what we discussed earlier with respect to binary ionic compounds will apply in this case as well, in that the total charge when they're combined together must be equal to 0, which means that these two plus charges here from the two sodium ions will cancel out the two negative charges from the carbonate ion, all right? So basically that's how we end up with the formula being Na2CO3. Okay, so in terms of naming, it's very simple. We name the metal part first and then the anion part afterwards. So the name of this compound here is sodium carbonate, very simple, all right? Again, this is just basically re-emphasizing something I said earlier. The charges must cancel out. This is the way the formula is written for the entire compound, and the ions are shown here. These are the ions that are actually present in the compound, but when you put it together, this would be the final formula. By the way, the name of this compound here is potassium permanganate, all right, just to let you know. This is called the permanganate ion, and this, of course, is the potassium ion, all right? Same thing applies here. This is the way the formula is written, and these are the ions that are present in the case of sodium carbonate. Okay, in terms of naming of the anions, right, there are certain patterns that emerges. For one, anions ending with ATE always contain one more oxygen than ions containing that ends with ITE, I'm sorry. So this is called a nitrite ion, and this is called a nitrate ion. If you compare these two, you see that the only difference between them is that the nitrate ion has one more oxygen compared to the nitrite ion. And you see a similar pattern when you compare the phosphite and phosphate, right? The phosphate having one more oxygen compared to the phosphite. And you see something similar happening when you look at the comparison between the sulfate and the sulfite, all right? So basically, everything else being the same, the 8 ending ion will have more oxygen, one more oxygen compared to the anion which ends with ITE, all right? Now, key thing you need to remember is that the terms ATE and ITE do not actually indicate the number of oxygen atoms, right? So you cannot tell exactly what the number of oxygen atoms are present based on the ending, right? All you can say is that the 8 has one more oxygen compared to the 8. That's simply all you can conclude based on the names. And there are some other things that you might see in the name of certain anions, such as per, right? Per means that basically the anion will have one more oxygen compared to the 8 form. So for example, this is known as a chlorate ion, and this is known as the perchlorate ion because it has one more oxygen compared to the chlorate, all right? In some cases, you'll see hypo, which means that the anion will have one less oxygen compared to the form whose name ends with ITE. So for example, this is called the hypochlorite ion, and when you compare that to the chlorite ion, you see that the hypochlorite has one more oxygen less, all right? So these are just certain patterns that you'll observe when you look at the name corresponding to the formulas. I will say, however, that you do not need to memorize these rules because, as I said before, the formulas of ions will be provided in the tables that I've posted in Canvas. All right. Now, there are certain polyatomic ions that do not use the 8-ite system, such as the hydroxide ion and the cyanide ions. Right. These two are polyatomic ions, but they do not use the 8-ite system. And the same is true, by the way, for the hydrogen sulfide ion and also the peroxide ion. So these are all polyatomic ions, but they do not correspond or conform to the 8-ite system. All right. And then we have polyatomic cations, and there are three of them, three common ones. We have met this one before, and I think we have met this one before, and there's also this one right here, right? Most of the polyatomic most of the polyatomic ions that are in existence are actually anions, but these are three common polyatomic cations. Okay, so this is just a list of different polyatomic ions and their charges. As I said before, the more comprehensive list is provided in that table I've posted in Canvas. And these are some compounds that contain polyatomic ions, all right? Their formulas and their names, all right? And that's pretty much it. So that's it for this chapter. So the next class we will be discussing how do we name, actually this won't be the end of this chapter. There's another topic, I just remembered. There's another topic that I need to cover, and I'll get to that. I'll post those videos very soon. But for now, you need to basically understand what we're dealing with when it comes to naming ionic compounds, because that's basically what we're going to discuss in the next class. All right? Until next time.